Okay, some announcement quickly first. If you're still on the waiting list, what you should do is you should really speak to the main office, Lassam Building 1012M. I have no power over official registration. However, I can add you to the Moodle so you can look at the lab instructions. Lab 1 is due next Friday, okay? Send me an email if you need Moodle access. Lab 1, need help? Come to tomorrow's lab session. I'll do some syntax walkthrough with you. That might be useful. So just make sure you come. And then my office hours, 4 to 6 p.m., Monday, Tuesday, Wednesday. Okay, every Monday, Wednesday, Tuesday, Wednesday. And for tomorrow, make sure you come. We'll show you some useful syntax if I cannot get to it today. So now, as I promised, I really want to handle this question which you guys asked last time. I think it's a very valid question. Okay, basically, how can the cyber contract be useful in guiding you through eventually to some valid design? Okay, I'm going to use a very simple example, like how we discussed last time, binary search. Okay, and then we're going to see how we can move from one version to a second one, and then to the final version using the design by contract, just to show you the idea quickly. Okay, let's see what the question is. Okay, the lesson to learn is DBC that we are trying to teach you this in this course is really useful. Let's see in what way. Let's try to define a simple problem over here. I already made the source code available to you in iPhone, so you can feel free to play with that. Remember curiosity, that's a key to success, curiosity. What we want to build, I'm gonna do some live demo to show you. We want to build a console application. As far as the client is concerned, they're going to keep entering some string names, Alan, Mark, A, B, C, D, some string names, randomly. It doesn't have to be in sorted order. And then until they enter done, that means we stop entering into the database. And then the client may inquire to see whether a specific name exists in the database they just initialized. Right? Let me illustrate to you until they say quit. Let me illustrate to you how that's supposed to work. Okay? So now if I just go to that terminal over here, okay? So now I already got executable from iPhone, so I'm going to show you. So I got actually 3 versions over here. So you just got to say -v1, -v2, -v3. Okay, 3 versions to see the story. So now, if I just go to the very final version, which is going to work eventually, okay? Let's see how the application is supposed to work. Enter a name or done when you're done, okay? Let me say E, C, D, A, B. So far, I enter 5 names to the database, okay? And then I'm going to say done. Okay, don't worry about the A, B, C, D over here. It has a special meaning. I'll explain that in just a moment. But now, since I'm done, so the database has only 5 elements, and now I want to start inquiring about the database. I want to see if A exists, B exists, C exists, F exists, or G exists, etc. Okay? Imagine that the database can get to very large, in which case we are better off to use a binary search for login performance. Agree? But for illustration, only 5 elements. So now let me say, if I say, does A exist? A exists. B exists. C exists. D, also E, also exists. If I try F, does not exist. G does not exist. Very simple console application. However, we're going to see how we can use a binary search within the program, which is kind of hidden from the clients. We will see for us as a supplier, how do we develop the application. Okay, so now I'm going to quit from here, and then I'm going to clear the console. Okay? Any question about how the program is supposed to work expectedly? Okay? So now let's see how we may implement this. From the supplier's point of view, us, we want to store all the names into an array. Okay? And then every time if the clients want to inquire about a specific name, we're going to do a binary search. So I have encoded the binary search in iPhone as well for your information. Okay, look at that for the syntax. So now we're going to look at 3 versions. Okay, I'm going to go over details with you. I'll point out where you should look at when you look at the source code. So now for all the 3 versions, you got 2 classes to worry about. So you got a class called database. Okay, I say just v1 for version 1. You got database. You also got utilities. In the utility class, I have the search method, which is binary search. Okay, I just don't show you the detail. Remember in lab 0, you can show contract view. So this one does not show you any code. Okay, so now we assume the binary search has the correct implementation. There's no bug in the binary search coding itself, let's assume, for all the 3 versions. And then for the database class, okay, notice that there's an arrow over here, right? It is a so-called client-supplier relation, which you are supposed to draw for your lab 1. I'll give you, I'm making some slides on giving you some tutorial on the drawing design diagram, which is required for lab 1. But this is just one small example. In this case, database is the clients, and utilities is a supplier. So whenever you're trying to draw the arrow to show this, you're going to go from clients to the supplier. Okay, that's the arrow. So for the database, we're going to have, you want to add a name. You want to check to see whether the data exists. And it is this method here or feature here that's going to call the binary search from your utilities. Okay? And then you can also try to make some empty database. Questions? Okay, before I go through this point over here, let me show you very quickly one point of the source code to highlight to you. If you download the source code, you will see under model, you go to version 1, go to database. Okay, that's IFO code. Okay, you should have some basic knowledge about IFO code already. Okay, let me point to you where you should pay attention to, first of all. You can see that the way I implement it is I also have a common ancestor class called database. In the database, I simply declare data as an array of string that will be inherited to all the 3 versions. So assume we have the database. We have the array called data. Let me go back to version 1. Tell me something. Look at the add name feature over here. Every time, if the client wants to actually add a name to the database, this is how we're doing it. Do you think that's correct? What it says is I'm going to insert to the end of the array. By the way, that's a force feature. So you will see some, maybe in the tutorial I explained that already. So you should know this feature. Okay? But now I can tell you that this one-line implementation here is simply trying to append to the end of the array. Okay? And then if you look at the whether database exists or not, we're simply calling the binary search, which we assume to be implemented correctly. Do you see anything wrong for version 1? And, oh, one more thing before you answer me. If you actually go to this particular search method here, you can see that one is implemented over here. Also, you got a recursive helper method, right? Like how you did for 2011 or 2030. This search method here has no contracts, no precondition, no postcondition, no class invariants, clean. Okay, maybe that's kind of corresponding to how you would do it in Java. Okay, okay. Based on what we learned about version 1, do you think that's okay? Yes? No? I can tell you the key really is at the point where when you are trying to call binary search. Is it going to be okay sometimes? Always? Good. I like that. What do you mean sometimes? Say it again? It will be okay if it is sorted, and it will not be okay if it's not sorted. Okay? That's the problem. Let me illustrate to you. For version number 1, let me show it to you. Let me go back to the terminal over here. I'm trying to run the same executable, but now I'm going to say V1. That's the one we just looked at. So now, let's say if the user tried to enter a sequence of names that's actually not sorted. And then every time we simply append to the end. So that means the array that we pass to the binary search is also unsorted. In that case, we might miss the search as we go through, right? Let's verify that. The same sequence, E, C, D, A, B. Okay? And then we say done. Okay, E, C, D, A, B over here simply means that's kind of the internal array representation. Okay, it's not sorted. Okay, it's simply append to the end. So now, if I say, does A exist? No. However, is this wrong or correct behavior? Wrong behavior, right? Agree? Wrong. That's apparently wrong. I added A, apparently, right? But it says A does not exist. Is this a good design? First of all, it seems like implementation itself is wrong, and design itself might be wrong too. Recall what we said last week. What defines a good design? Contracts? Contract is the second step, okay? A design is considered bad if, when something goes wrong, there is exactly one side to blame. Do we have any side to blame? No, it's silent. Well, we should expect to see some kind of contract violation at this point. We should, but we haven't. So this design is bad. Agree? And this, okay, try this. B also does not exist. It's pretty bad. C does not exist. D exists. This doesn't seem to be predictable anymore, this program, right? Let me quit. Everybody convinced? Version 1 is not good. Okay? Let me go back to the description over here. Summary. For version number 1, in the database, the array is not kept as sorted. That's the problem. And also utilities over here, the search does not require the input array to be sorted. They should be blank as well, right? Because if you're trying to do binary search, of course, you're going to say, I require the input to be sorted. But it does not require that. That's the problem, okay? And then, okay, so you can read the rest, but no contract violation. And we say that a bad design is when something goes wrong, no party to blame. Should we blame utilities or should we blame database? It doesn't tell. Okay, that's version 1. You can imagine that when you are trying to develop your lab 1 or your project or any software projects, you might always finish a draft version, version 1. And then you realize, let's say no contracts. You realize there's something wrong in the behavior, but I don't know where to fix it, right? Decide by contract can actually show you where you should fix, okay? So now let's go to version 2. In version number 2, okay, that's exactly the output, okay? So I just highlight. When you see the note, you will see I highlight the part that's not right. Let's move on to version 2. For version 2, the only change I'm trying to make over here is to make the design better, so I would know which side to blame. The only change I did is in the binary search method here, add a precondition over here. Okay, and you may want to study this syntax a little bit. I'm going to go over that a little bit later. But this might be useful to what you have to write for lab 1. Basically, what this is trying to say is for the array, it's simply sorted in the ascending order. Before you try to pass to me to the binary search, the input better be sorted. Otherwise, precondition violation. Okay? So that's the new addition, which means we're trying to use some contract to help us. And now, question for you. Would this particular new addition force the database side to change? Would it force it to change? In the previous version 1, it wouldn't force anything for the database because the system can simply just run without any exception. But now, if we try to run the same input as before, which means it's not sorted, is it going to signal something that's wrong? It is. Let's see. Okay? You're just trying to really catch the lesson here. It doesn't just apply to this simple example. You can generalize it to any project you're making. So now what I would do is I will go to version number 2, okay? Where we do have the precondition added for the supplier, which is utility side. And now E, C, D, A, B, and then I say done. The internal array by database is still not sorted, right? Now, what's going to happen if I start calling binary search for the first time? Is it going to be silent as before or precondition violation? Okay, I'm going to show you a little bit more clearly. If you look at that, it will tell you exactly in the stack trace. There is a tag for the precondition called array sorted, and that's exactly this precondition being violated. This is good because when the behavior is abnormal, it tells you where to blame. You should blame. Which class is to blame? Database, exactly. Because more specifically, if you look at the code, I'll show you very quickly. If you go back to the code over here, go to version number 2. If you go to version number 2 for the database over here, you can see we are still trying to maintain some unsorted array, But now at the point that you're trying to call this, it's going to give you the precondition violation. So that means the clients who's using the binary search is going to be blamed. So now it's a better design because I know which side to blame. Okay. Guys, questions? Okay, the story is not finished yet. We have just improved the design from the client side, the binary search, because now the binary search does require a precondition. However, the supplier side. The supplier side, we do have a precondition over here. But now, what about the client side? The client side is forced to make some change so that when you try to call the binary search, it's going to give you a sorted array. Okay? Any suggestion? Yes? Well, what you just suggested was, what if we simply say, let's say for data exist, you simply add another precondition, just to say the current array should be sorted. You can add a precondition, but it may not help so much for the developments because you're still going to get a precondition violation. You're still going to get some exception at the runtime. What you really want to see is, I do not want to see this precondition violation. Okay, I want the system to be silent and working.
When you do add name, it needs to be sorted so that you don't force it to the end of the array.
Exactly, exactly. So remember insertion sort back in 2030 or 2011? Okay, I'll just mention that verbally. Basically, want to say, we're assuming that the array start to be sorted. Every time you try to insert a new elements, insert to the right spot so that it remains to be sorted. Okay? It turns out the code is a little bit complicated to write, but I would suggest use it as a case study for you. Also demonstrate how to use loops. So if you go to version 3, I just want to convince to you, it's actually working. I tested it. So if you go to version number 3 for utilities, so now for the, not utilities. I should go to database. Database version number 3. If you see under add, it's now much more complicated. Okay? Which means every time I'm trying to add a new name to the database, I want to insert that to the appropriate spot so that it actually remains to be sorted. Okay? That's version number 3. So from version number 2, even after adding the precondition, now we have some runtime exception that will force us to change this client side to be appropriate implementation. Okay? So now let's go back to iPad over here. If you look at version number 3, basically, so right now, what's the story? We have this precondition over here since version 2, and also the add name over here has been corrected already. So now question for you, given these two fixes, are we going to get any contract violation at the runtime? Let's not worry about postcondition. That'll be something from my conclusion. Okay. As far as what we have got so far, we have only one single contract. If I try to run the same input as unsorted sequence, are we going to get a contract violation? No. Let's convince ourselves first of all, and then I will conclude the example. So let me go back here and then clear. And now let's go to final version, which is the initial one I just did. Okay, let's do it once more. E, C, D, A, B, and then done. So now you can see the sequence now internally is A, B, C, D, E, because we simply try to insert to the right spot rather than to the end. So now if you try to inquire, for example, A exists, B exists, C yes, D yes, E yes, F no. Okay, that works. No contract violation. However, we wouldn't be able to reach version number 3 without the contract violation in version 2. You agree? You really want to see why the contract is useful here. Because the contract we added in version number 2 caused the contract violation at the runtime that forced us to actually change the client database to make sure it's sorted sequence so that in version number 3, we have everything just working without any exception at the runtime. Okay? So now, final conclusion. If I go back here, okay, you can read just technical details, right? You can read it. So now, since everything is just working, so what we can do is you can notice that I try to draw a red boundary over here, which means we can now finalize and close the system. We're going to deliver this executable to our clients to say, now, as the clients, as far as they are concerned, they're simply going to input a string only. They don't have to call the binary search. They don't have to. They just enter the name and then try to say what name they want to look for. And then the program is going to tell them either something exists or something doesn't exist. And that's it. So you were asking me the question, why can we turn off the contracts when we finalize the projects? It's simply because while you're developing the projects, contracts that were turned on will guide you through the development so that you reach some correct code. But once the contract have served their purpose at the end, you don't need to check them anymore because they will not be violated anymore, like in version number 3. Guys, you see my point? Okay, that's really what I meant to say the other day, but it was messy. But now it's completely systematic. I hope you got the idea, okay? I would suggest, what should you do with this example? You should really go over the idea, get convinced the sub contract can really be useful. So here I only talk about precondition, but later on we're going to talk about postcondition class invariants. They will also serve their own purpose to help you get a better design for your code, for your projects. And then maybe look at the code to make sure you're really convinced that they work the same how you expect it. And think about this example. It will serve as a roadmap for you for the course. Okay. Questions?
So the reason why we're using binary search when searching for names is because we want to get a runtime of log n.
Let's say we want to.
Right.
Yes.
So I was going to bring up in your second version that since you're checking for a sorted array, doesn't that defeat the purpose because the runtime would be
You're basically asking the same question that Tammy asked me last week. So let me just go back here. Let's go to version number 2. You were basically asking this. For data exists over here, the precondition, the precondition we are checking over here is going through the whole array, which is big O of n. Agree? And then the binary search that we are trying to do, binary search, which is the implementation, is big O of log n. It seems like this is going to compromise the efficiency for big O of n. Okay? It is true. When you are trying to develop your code, it is okay to have the overhead for the performance for the contracts. That's okay. The main purpose for checking the contract is we are trading performance for validity of your design. Okay? As soon as those contracts already serve their purpose and now you're at the point to finalize your project and deliver, you can turn them off. That'll be fine. So eventually, when a client is trying to run an executable, those preconditions wouldn't get checked simply because they wouldn't be violated anyway. Yeah.
So first, what he did was trade performance just to
Make sure the contract can actually help you to get it right.
And in your final version, you just incorporated your precondition as part of the implementation while still acquiring log.
Or you can, yeah, that's true. You can think about, yeah, that's exactly right. And think about the contracts, not only that it can help you to do some testing for your implementation, but also it serves as a documentation, right? You can always show the contract view for your classes to see what should be expected beforehand and afterwards for a particular method.
I don't know, I find it kind of interesting because you say the precondition is often client on the issue, right? Therefore, we, as the supplier, system as a supplier, implement a method of search and sort that takes care of essentially the obligation of the client to make sure that it's sorted. So I don't know, I find that kind of interesting.
No, let me interrupt you. Okay, so basically, see over here. This is the supplier, the service we're trying to use. And then for me as a supplier of binary search, is it possible for me to implement binary search when the array is not sorted? Is it possible? No, right? Because if you might just go to the wrong end when you forget about the other half. In that case, for me as a supplier, I'm just simply put as my interface view to say, now, in order to call this service implemented by me, you better make sure the input is sorted. Otherwise, I reject to even call my implementation. That is why when we are calling this in the version number 2, this particular wrong implementation is going to cause the violation, right? Yeah.
But if you don't understand how to solve it in version number 3, is that we implement the search and sort to kind of sort that, right? So I don't know, I find it kind of interesting because
Yeah, exactly. So that's kind of the process, right? So you want to make sure you specify the contracts, and then the contract will force you to reach some like a balance between the implementation contracts, right? Yes. Okay. How about just take 2 more? I know you guys are into it. That's nice, but yes.
You said you turn off the contract
At the end,
at the end.
when you finalize the projects.
What if the person enters the wrong value? It should be on, right? Because then it's invalid.
Oh, that I'm simply trying to. Oh no, the person cannot enter the wrong value because now this version here. Remember, for this version here. Okay, let me just repeat. Okay, emphasize again. So if you remember the final version that I demonstrated over here, version number 3 is going to work regardless of the order of the entering sequence. If it is sorted, it's going to work. If it is unsorted, it's also going to work. So that's fine. Okay? Okay, final question. How about that? Okay. Yes. Go ahead.
We used insertion sort to order our.
It's a part of the insertion sort. How about that? Yeah.
But does not run an old end time anyways, which still defeats the purpose of trying to achieve the log of end time?
No, actually, so it's about different timings. Okay, I'll just mention that quickly. Okay, so again, it's I'm just showing you a particular design which may not be good enough, right? At least it's better than version 1, right? Okay, so basically you were concerned about in version number 3, after we have fixed everything, now the add name, which is going to insert to the right spot, that one is going to take big of n. And then when you try to check to see if the data exists, it's going to big of log n. Right? So maybe, again, it depends when you're back in 2011, whether this might be good or bad depends on how frequent you do insertion and how frequent you do search, right? That's something that's kind of outside the scope, right? All right, guys, I would love to discuss this with you further, maybe during my office hour, if you got more concern. Think about it, okay? After this, I will just go back to a little more example, okay? So now the idea would be, we want to talk about basically why we are choosing iPhone. I really want to talk about this quickly, okay? The reason that, okay, let me put it a little bit more in an informal manner. The reason that we are using iPhone is simply because Java would be horrible for doing design. Java would be fantastic, to my point of view, for doing implementation, like your 2011 class. However, for design purpose, where you have to use a precondition, postcondition, class invariant to help you design, Java may not be the choice. Now let me show you an example. And while I'm talking about this, I'm going to explain all the contracts idea, and also I'll show you some syntax for iPhone, why we're going. Okay? Now, let's now set the context. So the problem we're going to talk about is a simple bank accounts. Okay? So the bank account, if you see the slides, we got 1, 2, 3, 4, 5, 6 different requirements. For the purpose of this example, we want to make it simple enough. We only address the first 2 requirements. Okay? However, you will see how you can address requirements 3, 4, 5, and 6 in a later lecture when we talk about how you can write complete postcondition. But for the purpose of the example, we only do 1 and 2. Okay? Let's go over 1 and 2 quickly. Okay? Let me go to 1 and 2. Okay, so now requirement number 1. We have bank accounts. Each account is associated with name and also integer balance. For simplicity, we don't put real number, integer balance. Always positive, okay? We may withdraw an integer amount from the account. That's the requirements. You might find that, as I said before, in the requirements, it may be incomplete, it may be ambiguous, or it may even be contradicting, okay? If you got that thought, hold it. You're right. Okay, we're going to see how we can do this in Java, okay? Basically, we want to implement Java code such that it can be considered as a valid design. What can be a valid design? When something goes wrong, exactly one party to blame, rather than being silent, okay? As we illustrated in the simple example, binary search. Okay, let's go back to slides here, and then let's see. Now, let's start with some code. Version number 1. So this slide just to show you, I already posted all the source code for Java, all the 5 versions we're going to go through, and also the corresponding equivalent version in iPhone. Again, curiosity, right? Look at that. Play with them. And then you can download the source code, and then that's how you can import the product. I should know that. Okay. And then in order to play with the Java example, you have to enable assertions in Eclipse. I also got a tutorial to show you. Okay? Play with that. So now, version number 1. I'll show you very quickly. Version number basically will be very conceivable from how you understand Java. Okay, we got account version 1. We got 2 attributes, owner and balance. And then we got get owner, get balance. And also we got constructor, which will take the owner, take the balance, and then initialize them. We have withdraw, which will try to withdraw the amount and decrement the amount. Straightforward. And then we got toString, okay, just for debugging purpose. Okay, that's about it. Version number 1. Tell me if you think this is a valid design. Is this a valid design? Is it a good design? Okay, now tell me just one thing you think that's problematic. One.
So it says that the account balance has to be positive, but if you input an amount that's more than the account balance in the withdrawal, then it becomes turned into negative.
Yeah, for example, oh, you mean for the withdrawal or for the constructor?
For the withdrawal.
With withdraw, if you put negative. So the current bank is very magic. You can actually withdraw minus $1 million from that. It allows you to do that, which is pretty good. But that's not the correct behavior, right? And that's one. Withdraw shouldn't allow negative number. Anything else?
When clients initializing, they can make it a negative balance.
Yes, I can also initialize the account with minus $1 million, which may not be nice, right? Anything else? How about this side? Jordan.
What if the owner was no with a crash?
Oh, you mean the string, the owner being, don't worry about, we got something called void safety in IFA, which will do some check for you at the compiler time, so you don't have to worry. Something logical. Something to do also with the withdrawal. So, again, as I said, exactly right. So now the bank is also very nice. If I only got $10 in the account, it will allow me to withdraw $1 million. That's also very nice. You can see the account. This bank is really good. I wish there's a bank like this in reality. Okay, so there are three design flaws. However, if you simply try to run all the 3 problematic scenarios, negative initial balance, negative withdrawal amount, or too large withdrawal amount, is it going to give you any error? No, that's bad. Let's see that very quickly. Okay, that's really the issue. And then that's why we got so many later versions to really improve using contracts. Okay, so now I'm gonna just show you the code very quickly. Show you on the iPad. Okay. Okay, that's the code. Sorry, over here. That's the code. So now for the first one, if I simply give you minus 10, right? If I simply give minus 10, it simply will just do it without giving me any exception. Agree? And also, the second scenario, if I try to withdraw minus $1 million, in this case, that means I got amounts being minus $1 million. In this case, it will simply do it. No checks whatsoever. Okay? And also, if I only got 100, but I'm trying to withdraw 150, is it going to complain? No. Okay, you can verify that. It will just tell me, now I got minus 50. Who cares? I already withdraw. Right? That's not good. That's the problem. So now what we need to do is to see how we can fix it. So we can result in another version using precondition. You guys have already seen precondition. However, let me ask you this. How would you implement preconditions in Java? Exactly. Good. For those of you in 2030, I'm not sure if I ever said that to really implement precondition, I'm not sure if you pay attention to this subtlety. I actually said you can approximate preconditions in Java using exception. I didn't quite say you can implement preconditions using exceptions. Approximate is really the key term, which means exceptions in Java is not exactly precondition that we are talking about. Okay, let me explain to you why. Let's go over some slides over here. So now here, okay, version 1. Okay, we have seen that. Okay, everything I've said in the iPad. Okay. How should we improve it? Let's talk about precondition first. So precondition, this is my definition. Well, that's definition you should know for this course. Think about precondition as surface condition. Under what condition will the clients, under what condition will the supplier be willing to provide their service? If the precondition is not satisfied, the supplier is not willing to provide any service. Okay, that easy. And then we're going to see, what about this? What will be the precondition for that? You want division by 0. Okay, now question for you. If we talk about surface condition, what would that be? Under what circumstance will you divide?
Y is not equal to 0.
Exactly. So if y is not equal to 0, I will be willing to surf. However, how would you do this precondition, approximate this precondition in Java?
I put an exception.
However, will you say if y is equal to 0, I'm going to throw an exception? But now, you see, there's a logical negation over here. Do you see that? I'll show you what I mean. Basically, that's the main points. Okay, so now what I would do is, okay, let me just add that's really important to see. So now when we talk about precondition, it's about surface. When we talk about exceptions in Java, it's about under what circumstance are we going to signal an error. Okay, let's say for divide. And then we got x and y. Okay, so now, what would be the precondition? Not equal to 0. What will be the exception? I'm just writing in Java. Okay, so now that's why I said exceptions in Java is not exactly precondition. It's the logical negation of precondition. It tells you under what circumstance you're going to signal an error, rather than saying under what circumstance you're going to serve the function. Okay? You guys are computer scientists, so that's exactly the precise message I'm trying to send to you. So what you did previously for exceptions in Java is not too bad, but it's not directly precondition. It's logical negation. Okay? Good. But if you want to work at the design level, you want to think more about surface condition, right?
Does that also give a performance issue?
Performance issue? Okay. What do you mean performance?
Example, let's say any number that you input, the first thing it would check is if y is equal to 0, right? Versus if y does not equal to 0.
Yeah, so remember, okay, you talk about whether checking the contrast will be inefficient. Again, from the first example I started with today, during your developments, contracts being inefficient is not a concern because their primary duty is to help you, to guide you through the design to a correct one. You're going to turn them off anyway, eventually. Good question. Yes. Yes.
I get that they're different logically, but don't they serve the same purpose?
They kind of serve the same purpose. I agree with you, but thinking this way, it's a more subtlety issue, philosophical. How about that? Precondition itself really means for the supplier to be willing to provide a service to you. Under what circumstance would they provide a service? In that case, that's more like a precondition. Exception is more like under what circumstance is the supplier going to refuse the service? Yeah, just different way of thinking it. Yeah. More or less the same. Yes.
You said with Java it approximates?
It approximates in the sense that it does not directly talk about the surface condition.
Okay.
Instead, it talks about the negation of the surface condition, which is exception, which is error condition.
So is there a situation where it won't cover it?
No, actually, they are logically the opposite, right? So I would say from the external user's point of view, it may not make a difference. But when you're thinking in terms of your design, you better think in terms of surface condition as opposed to error condition.
Another question, you said, so IFL is a good design language, and you said Java is a good implementation language. So I'm just trying to make sense of it logically. So would you design something and then implement it using something like Java?
Okay, the question was, if I said IFO is very nice for design, whereas Java is very nice for implementation. So at the design level, should I maybe choose IFO and get something just to work as a prototypical implementation? Maybe the implementation itself may not be so efficient, but at least I have the correct contract, etc.
Well, do I use
Yeah.
both?
You know, I would say, yeah. Yeah, so that's more like an ending remark I would like to make at the end of the course. So yes, you may want to do that. When you at a design level, you may want to use a language like IFO to really help you think about pre-post conditions and class invariants. Once you get to that stage, you can translate whatever implementation you have into maybe Java for delivery. Yes, you may. Yes. Yes.
So in this case, it's a matter of clarity. That's why it's a better
It's a matter of clarity, exactly. But in terms of functional functionality, it serves pretty much the same purpose. Yeah. Okay. Okay, very good. So that's about it. And let me go to the next slides over here. Okay, one more. Oh, you know that, right? Array is sorted. I asked that as well. What about performing a topological sort? It should be directed acyclic, right? It's a DAG. Okay. Good. And then you will see other precondition to be written for the lab. But I'll give you one example today for sure. Hopefully I can get there. Okay, so now let's go to the next one. How can we improve version 1? So now in Java, as I said, the best we can do is to encode the logical negation of the precondition, right? That's the best error condition. Let's see that. Okay, let's see. Okay, so we're gonna say when y is equal to 0 for divide, we're gonna give you exception, right? Similar. So now, okay, that's exactly what I just explained. So these are exceptional conditions in Java, which is not quite service condition. Let's look at a new version of code quickly, okay? So now account version 2, and now we got, okay, if balance is less than 0, at the constructor level, we're gonna say balance negative exception, okay? And then for the withdrawal, make sure amount is, if it is negative, then it should be an error. If the balance is not sufficient for the amount you want to withdraw, then there should be also an error, okay? Let's talk about Java, right? I'm kind of trying to switch between, so just make sure you don't get confused. So now, this may work, but we want to criticize on that. Anybody want to criticize? Well, I would say, apparently you cannot turn the contrast off, right? That's one thing, right? It's part of your code. So somehow you're mixing design and implementation together. That's one. What's more severe is this is the supplier. Now, if I am the user, the client of this particular class, is it going to complicate my code unnecessarily? How? Exactly right, right? In Java, there's so-called check exception, which means if your class is like a balance negative, withdraw amount too large, they inherit directly from exception. That means if I want to call withdraw, if I want to call this constructor, I might say, try this particular method call, catch the different exception over here. That complicates my code. Why should I do that, right? Because if I already established the precondition you're hoping for, why do I have to write all the try and catch? What if there are 10 different preconditions for this particular method? How many catch should I write? 10. No, not acceptable. You can write it, I don't want to. Right? Guys, get the point? Okay, it's also mentioned in the slide. I'm just trying to mention to you. Okay? All right, so that's about this precondition here. And now, you guys did a little bit worse than last semester. A little bit. Not too bad. You guys are doing well. Okay, I'm just trying to point out. Look at line number 13. There is something. Do you think there's something wrong there? Subtlety, right? Okay, tell me. Okay. You want to try? 13. Do you think syntax is fine, right? Logically speaking, do you think 13 might be okay? Because what if, I'll explain this on the iPad. I'll just mention that. So 13 tells me I will give you an error if balance is strictly less than amount. What if balance is exactly equal to amount? Am I going to give you an error? According to the code, you wouldn't, but you should. Because if I got balance and amount being equal, I will get 0 balance eventually. Would that satisfy requirement number 1? The balance being positive? No, right? Also something wrong over there. Okay. Okay, I just want to mention that. It's also on the slides, don't worry. Everything I say is on the slides. Okay, so now version number 2, and now why better? Okay, so now very easy to see. I'll show you very quickly on the iPad. Okay, basically I'll show you one. Okay, so now you can see that over here, what used to be the case, what used to be a concern, if I got minus 10 to initialize, and now if I got minus 10 over here, being the initial balance over here, so now minus 10 less than 0 is going to be true. That means I'm going to give you an error. I refuse to serve the constructor because you're going to give me an error, or give me a negative balance initially. Okay, that's why it is good. It's a better design because now we know that the client should be blamed. Okay, similarly, if you try to withdraw minus 1,000,000, you're going to get a corresponding exception, right? Okay, if I do minus 1,000,000, so that means if I got minus 1,000,000 and then minus 1,000,000 less than 0, agree? It's true. In that case, of course, I'm going to get this particular withdrawal negative amount exception. Okay, that's also good. Because when something goes wrong, it does blame somebody. Okay, finally, let's say if the initial balance, oh, by the way, look at the client's code. Bank app version 2 is trying to make use of account version number 2. However, I'm only trying to do these lines of code. I just want to make a new object. I want to make a new object. I want to withdraw. That's all I want to do. But I need this kind of stuff to write. That's exactly my point. Why should my code be polluted by the supplier's exception that they declare? That's really the point. On the other hand, if you try to do this in IFO, that's why I argue IFO could be a nicer language for you to think about design. You only say from the supplier side, say require, for example, the withdrawal amount to be larger than 0. However, the clients using it, do they have to do any try and catch? They don't have to. They got to make sure when we call this particular withdrawal, you better make sure the amount is positive. Otherwise, you got contract violation at the runtime, right? But the client's code doesn't have to be polluted. That's the point. Okay. Okay. After this, okay. So now, critique. Okay, that's exactly. I promise I'll come back. Now, I want you to pay attention to this particular precondition, right? Error condition. I shouldn't say precondition. Approximated precondition. We used to say. Oh, sorry, not this one. This guy here. Line number 13. Balance should be strictly less than amount. But let's see this. Let's say the initial balance is 100. I'm trying to withdraw the same amount. Let's try to get around this, okay? Let's trace very quickly. So now let's say you have over here the amount is simply 100, right? And then, so that means when we are checking this particular error condition, amount is 100. And the balance is 100. 100 less than 100? Don't tell me true. False, right? Do you need explanation on that? Should be okay, right? Okay, that's false. That means we don't really go to the error. So now, that means after this, we don't have any exception. So we simply tell you initially, finally, you get balance 0. But this violates requirement number 1, which means always positive. So that means version number 2, even though it does fix some design flaws from version 1, it's still not perfect. So now, continuing from here, I'm going to make some new contracts for you. Okay? And let's see. So after this, we're going to see some slides. Okay? So version number 2, okay, we have already done. Everything has been said. Okay? Don't worry, I'm not skipping anything. Why it's still not a good design? Because if you try amount being equal to balance, you're going to get negative balance. Okay, so now what we will do is we'll now go to improvement. One way to fix this, in order to prevent this from happening, of course, you can make less than or equal to, right? You can add an equal sign. That's one way to fix it. Another way to fix it is to think at a more global level. And for this, we need a concept about class invariance. And the best way for you to remember class invariance, if you ever took this course with Jonathan, another instructor, he will definitely mention the number 1 important concept for the course is about class invariance. It's very important, actually. Okay, let me explain to you visually, quickly. So now, let me see bank version number 3. We'll get there. So now, let me add a new page. So we'll talk about class invariance. Thinking this way, I'll make it very precise. At the compile time, when you are developing your code, you have some class over here. Okay, some class. I'll just write in iPhone. If I declare any invariance over here, let's say I'll say some Boolean expression P. It's a Boolean expression. So what does that mean? The consequence of having this is, at the runtime, because we know we can instantiate this particular class for as many times as we like. For example, let me just make a concrete example for you. Let's say you simply say, heap. Do you think that might be your concern? Maybe, right? If you don't know what I'm talking about, you're in trouble. Okay. So now let's say invariant is, you should satisfy the heap property, maximum heap property, let's say. The consequence of declaring this invariance over here is, for every runtime object you have, you may have heap number 1, heap number 2, and heap number 3, different instances. Every one of them, throughout the lifetime for each object, they should always satisfy P. When you are trying to update any of the heap objects, as soon as you violate, let's say you're trying to insert a new element into the heap, as soon as you violate this P, you're going to get violation. Okay? So class invariant is more like a global property, integrity property. For example, account, the invariant should be, every account should be positive balance. And yes, question. Something like that, yeah. So don't get too much into the example. So think about in a higher level. Invariant simply means every runtime object for this particular class, starting from the time they got created until the object got deallocated, they should always satisfy this invariance. As soon as it is not satisfied, you're going to signal some contra violation. Okay, yeah. So let's see some example over here. Okay, we do have some example for you. That's about class invariance. Okay, let's go back here. So we're going to do invariance example. What about CS major student? What will be your invariance? Under what circumstance will you be kicked out, for example? GPA, right? Okay. Okay. GPA larger than equal to, is that right? Or it's actually, it should be higher? 4.5, okay, good. Yeah, anyway, okay, yeah. I'm sure you're satisfied with that, I'm pretty sure. Okay, now, this will be interesting to think about. What would be the invariance? We talk about precondition for binary search, right? Don't get confused. Now we talk about for every binary search tree, what's the property they should satisfy? As soon as they get dissatisfied, there should be some contra violation signal. Yeah, exactly. Okay, yeah. Basically, let me just go back here. If I have a binary search tree, okay, sorry, I don't know how to draw. Let's say root, left subtree, right subtree. Basically, every node here must be strictly less than the root, and every node over here must be strictly larger than, right? Search property, okay? And hopefully by the end of the second week or third week, you would know how to write this and test it at the runtime. Okay, so now let me give you another view. This is absolutely right. I'm not saying that's not correct. Okay, that's very good. What if I try to do an in-order traversal? Of the binary search tree? What's going to be the result? It should be a sorted array. So the invariance for the binary search tree, you can either encode the search property, or you can say, doing an in-order traversal, which will give me a sequence that's going to be sorted, always. As soon as it's not satisfied, we're in trouble for the binary search tree. Okay? And I believe you have to implement the invariant for the heap. Okay, I'll let you worry about it. Okay. Question, yes.
How is it going to be different sometimes from the precondition postcondition? Because when you talk about withdrawal or class invariant is that sum of the elements and the balance.
Very good question. So what would be the relationship between, okay, we talked about precondition already, right? And now we're adding invariants. Think of invariant as being checked at the end of, you know what, can you hold this question here? I think it's better to talk about this relationship when we talk about postcondition. Okay, but you can think about invariant is really important. Every time when you try to attempt to do any operation on your data structure or on your objects, at the end of the operation, you want to make sure the invariant is still maintained. That's the important key.
So there are times that you check one property two times.
You only check it at the end, yeah. Okay, the question was, okay, let me go back there. The question was, let's say I'm trying to make a method call. Let's say account acc.withdraw. You're basically asking, should we check the invariant? We definitely should check the invariants after this, right? To make sure the balance is larger than 0. Should we also check beforehand? That's your question. The answer is no, because it's unnecessary. You will see why. It would be sufficient if you simply try to check the invariants at the end of every feature call. That'll be enough. You don't have to check even before. That'll be redundant. Okay, we'll see. Okay, hold that thought. Okay, after this, let's go back here. Okay, binary search tree. Oh, thank you. Okay, good. Oh, thank you so much. I don't want it to black out, actually. That'll be very bad. Thank you. Forgot. Now it should be good. Okay, so now how can we implement invariants in Java? Not exception. Anybody use assertion before? I didn't teach in 2030 to be fair, so I wouldn't expect you to know, but that's okay. For those of you who are very good in Java, so there is something called assertion in Java, which means at a certain point, I can simply assert some Boolean condition. If the Boolean condition is simply true, I pass, as if the assertion is not there. If it fails, it can give me assertion error. It's kind of similar to exceptions, except that assertions, well, think it this way. If I say this particular method may throw a count, let's say I have the withdraw method. Okay, let me make it clear to you. So now if I have withdraw, okay, some amount over here, and then I say if something happened, I'm going to throw some exception over here, right? What you should notice is, the good thing about this is this will appear as part of the API. Because if you generate an API Java doc for this method here, you will see this method can potentially throw this exception, agree? That's part of the interface. However, if you try to use simply just assert, it's going to be private. It's going to be hidden. Is that a good thing? Yeah. Well, assertion itself being hidden is nothing wrong, because you're just simply asserting if your code up to this point is correct. However, using assertion to approximate class invariant, is that a good idea? Is class invariant supposed to be private or public? Because your client, when using it, they should know. They have the right to know what will be the integrity constraints for this particular object. So assertions themselves is okay, but using them for class invariant is a bad idea. Okay? You may use that, but again, you are back to the same drawback, because you gotta encode a logical negation for that constraint, number one. Number two, you have so many, you got even more try and catch. Imagine that I got 100 class invariants, I got 200 precondition. Well, I'm just exaggerating it, right? That's not good, either way. Sorry, questions? Oh, sorry, I'll let him first, and then I'll come to you. Yes, go ahead. Okay, basically, think it, when you try the assertion, you can try, when you download the Java source code, try the following. you would see withdrawal method got a single assertion over there. When you try to generate a Java doc for the withdrawal method for the account class, you wouldn't see the assertion itself appearing on the public API, which means for me as a client to use the account class, I have no idea that the class invariant is actually this. That's my point. However, if you try to use IFO with the invariant clause, the keyword is always shown in the contract view. That's why. Yeah. Yeah. As far as checking something is concerned, maybe trying to achieve the same purpose, but it's actually not so nice because you want the client to see what the invariant is. That's the point about design, right? You want to be as transparent as possible. Okay, so now that's about class invariance. So now I would just want to, okay, that's just syntax for, that might be for your interest. You can use that maybe later for your Java code outside this course, okay, just for assert. We might say for the students, we say assert, this GPA larger than or equal to 40.5. We can say assert in order is actually sorted, right? So now question, where should we put this assertion? Let's say in the case of the account class, right? So far we got constructor, we got withdrawal, right? So now, how many times should we put the same assertion? At the end of, okay, you said at the end of every call. Yeah, when you say at the end of every call, that means you're trying to assert at the client level, not at the supplier level, right? Okay, so now, supplier you should really, okay, let me show you, this is what you should do. Okay, let me show you quickly. This is what you should do. So this is a supplier, right, for the withdrawal, right? So now I'm putting that at the end of the method, which means after I have done the withdrawal, I want to make sure I still maintain the integrity for the account objects that's currently being manipulated. So I'm saying that, okay? Rather than saying the bank, the bank app is trying to do this assert. No, the other client, they shouldn't be concerned about this, okay? Should there be anywhere else? Assert, yeah, withdrawal, right? So 2 places. And now, can you see any drawback of this approach? Exactly right, that's repetitive. If you got more than 10 methods, which is very common, if you got more than 10 methods for this class, you got to repeat this 10 times. If you got this repeated 10 times, let's say one day you decide that you change your requirements so that you want to change the invariance. How many times do you have to change? 10 times. This violates something called single choice principle, which we'll emphasize a lot. Okay, just learn this name just for now. I'm gonna talk about it more formally. Single choice principle. Every time you got something being repetitive, that means your design smells. Back in 2030, I said, if you got repetition, that means your code smells. Your design can smell as well, okay, when you got repetitions. Yes?
Make a function called invariant and just have that there. So
yes, you may have a function call. Yes, you may. But still, you have to repeat that function call for many times, right? You still have to. I agree. That'll be better. What Jordan suggested was you can simply make a method call which will do the assertion, but you still have to put the method call at every spot. However, if you simply put an invariant clause in the IFO class, only a single place, okay, it's going to be checked properly. Okay, so now we're going to reach the most interesting concept, postcondition. We're going to get there. Okay, so after this, we're going to see, right? So that's version number 3. We got this assert, this violates. I'll write it down. Single choice principle because of repetition. Okay, we'll get there. So now for version number 3, so now if I try to withdraw 100 when I only got 100, right? So that means I'm going to violate this assertion over here, right? So when I got 100 over here, and now after this, the balance is simply just get to 0. 0 larger than 0 will be false. I'll give you assertion error, okay? Very good. Okay, so now, question for you. Look at the same code over here. Now, in order to introduce postcondition, think about the following question. At the moment, let's say the client behaves very well. They give you an amount that is not negative. They give you an amount that is not too large. Also, they make sure they don't violate the invariants. The client behaves very well. Supplier got all the benefits. Does this code specify any obligation for the supplier? You might be saying to me, wow, it seems like it's very straightforward, just decrement the amount, right? Who can get it wrong, right? Well, true. Well, actually, you'll be amazed. Somebody can get it wrong. But my point is, let me illustrate to you. Easy. Now, this is the current implementation. Okay? Let's say I want to withdraw $1 million from my account. And somehow, there's a conspiracy between me and the supplier. And then it will simply change that to plus. So rather than withdrawing $1 million, it's going to increase $1 million to me. Okay? Now, something must have gone wrong. Agree? Is there going to be any contract violation in this case? Because, well, my balance is simply just get incremented, so this will definitely be satisfied, right? However, there's no constraint on the supplier side as to how they are supposed to do the implementation. So now this apparently is wrong implementation, in which case it does not get caught by any contracts. That's called postcondition. Yes, go ahead. That's correct, but that's not exactly something we're going to talk about. The lesson is, let's say the client has done everything they're supposed to do, but what about the supplier? We're going to be fair, right? But now we have obliged nothing on the supplier side. That's what the postcondition will do. So when you are trying to develop your features or methods at the design level, not only that you want to think about what should be the precondition in order to serve the feature, but also if the precondition is satisfied, what would be the kind of service I want to provide, right? That's also important, okay? Of course, this one is only a flavor about postcondition. I do have a slightly more complicated example for you, which will help you for the lab, okay? We'll get there. We're still doing good in time. Okay, so this guy here is not good. If we got wrong implementation and then nothing, well, signal an error at the runtime. So it's still not a good design, okay? Okay, exactly, right? So if I simply got this, the balance is simply, okay, just do plus, that's apparently wrong. Okay, it's wrong implementation. In that case, wow, isn't that nice? I got balance 100. I try to withdraw 100. Oh, sorry. I try to withdraw. Oh, okay. I got one. Oh, sorry. Let me say it again. What am I saying? I got an initial balance 100. I tried to withdraw 50, but I got 150 at the end. That's not good, right? Good. I'm glad you agree with me. Good. So this is not good. So now we're going to talk about postcondition. Okay, so now, okay, invariant that we talk about, okay, it's going to be fine. Okay, and now version 3 is not a good design simply because if something that goes wrong, something that's wrong from the supplier side is going to be an issue. Okay, let's just go. I'm a little bit behind on the slides, but everything has been said. Okay, the withdrawal is wrong. In line number 9, it's wrong. But now nothing will actually signal an error. Okay. Okay, that's where I'm up to. How should we improve it? Postcondition. So this is the most difficult one to get through. Okay, because in order to get a postcondition right, in the most complicated case, you may have to deal with collection, like an array or a tree or a graph. Not only that, you have to worry about not just the local spot you're trying to change. You have to worry more about the global structure. Okay, I'll illustrate to you. Okay, postcondition, we want to say upon the completion of the method, what should be satisfied? That's postcondition. Okay, so now this relies. Okay, yeah. Okay, yeah. Assuming that the precondition is satisfied, of course. So now, what would be the postcondition for divide. Let's do that very quickly. What will be the postcondition? How can you constrain this implementer for divide such that they can do, if there's anything they do wrong, we can catch them? Let's make the following assumption. Whatever x and y you pass, let's say there's no remainder. You divide perfectly. Let's make the assumption.
Instead of dividing and multiplying.
Huh?
Instead of actually dividing, it multiplies. They don't do the right operation.
Yeah, exactly. So you're giving me one example of how things can go wrong. My question is, in order to catch such errors, how can we write a postcondition so that it can catch that? Yes? Exactly right. That's exactly right. So now in IVO, for any query, you can use the result. So result times y will be equal to x. Okay, it's a simple one. Okay, so this will make sure anything you do wrong, for example, the one you just mentioned, you wouldn't satisfy this, right? Good, very good. What about binary search? What will be the postcondition for binary search? Let's say the binary search is simply going to tell you yes or no, right? Whether it's there or it's not there. Yes. You may go through a data structure, yes. You want to say if the result happens to be true, that means the element must be there, right? Yeah, something like that. Okay. Basically, we're saying result being Boolean, if and only if, like equals, basically equality. X is a member of XS. You can easily use a has feature in array, okay, like a contains. Okay, that's easy. Okay, so now the best we can do for postcondition, again, is by using assertion. Of course, you can use exception as well if you wish, but we're going to fall into the same drawbacks as we said. Okay, so now version 5, that's the final version. You can think about this. Okay, think about what we're doing here. It's very important. Because now I want to make sure if I want to do withdrawal, the old value for the balance must be strictly larger than the new value for the balance after the withdrawal. Agree? Okay, so now I need a way to cache or to store temporarily the old value so that it doesn't get lost. Okay? So now make sure you're comfortable with this. So now I just have a new variable over here just for the purpose of contracting. Old balance should be this balance and do whatever I want to do. And apparently, let's say either this can be wrong or correct. At the end, I'll say the balance after the withdrawal, there's a new version, is equal to the old version minus amount. Are you okay with that? Okay, let me, for those of you who might be a little bit lost, let me just try to highlight it here. This is really important. Okay. What you want to see over here is, let's say the current balance, let's say is simply 100, and we are trying to withdraw 50, let's say. And then let's say the implementation is simply wrong. It's plus. Okay, let's see how it's going to go. So now, when we try to store this value over here, what will be the old balance? 100? Very good. And then, after this particular wrong implementation, what will be the balance? 150, right? So that means when I get to this point, when I evaluate this get balance, it will give me 150. What's the old balance that I just stored? 100. And then 50. 150 equals 100 minus 50 is false. That will give me a postcondition violation. So this is good contracts, good design. However, when postcondition gets more complicated in the sense that it involves many components of your system, you don't want to store every component manually. So here, since we're only concerned about balance, so we got to store all balance. What if you got other attributes? You don't want to do this manually, do you? However, this slide is actually very important. It gives you insight. This is how IFO implements contract checking at the runtime under the hood. I will revisit this mechanism a little bit later. But you can think about whenever you put any postcondition in your IFO, and if you refer to the O keyword tells the IFO compiler at the runtime, before you try to execute this particular withdrawal, cache that value first, so we can use it. Okay, for that part, I'm being a little bit vague here, but I will get there a little bit later. For now, just make sure I understand this fragment of code of Java. That'll be enough. Okay, so now let me just make sure I'm ready to go to the example I want to show you. That's about postcondition. So now, This is a general principle for postcondition. You want to somehow relate the pre-state value and the post-state value in a way. Okay, that's a principle, but we're going to see example for sure. Okay, we'll see. Okay, why is better? Because now you will get assertion violation, right? Exactly what I just showed you. Okay, over here. Okay, that's the false, right? Okay, so now if you want to just have a summary over here, this table simply summarizes basically the Java version number 5 we got may be a good design, but the kind of scaffolding you have to do, try and catch, if the else, try and exceptions, assertion, or etc. And also to manually store all values in order to do post-condition checks. That's kind of the stuff that will distract you from design. You don't want to do them when you want to think about just the design. That's why we choose a language that's going to do all this kind of stuff under the hood for you. That's IFO. Okay? That's the main rationale for choosing IFO. Not just because we like IFO. It's not that. Okay? There's a reason for that. Okay, I would say please go over the Java example, even though we don't test you on this Java example here, but I think it gives you some motivation and rationale for why this course should be designed this way. Okay, so now you can also see the table for benefits and obligations. I want to spend very quickly another 7 minutes or so. Let's do one example for postcondition. That will help you for lab. And then we'll talk about, okay, finally, you should really study before next lecture up to slide 36 at least. Okay, that's going to finish all the 5 versions for the Java. Okay, what I would like to do now is to so I plan to do a little bit syntax review for IFO. I'll do that in the lab session tomorrow instead. Okay, so just make sure you come. So we'll do some demo. And now I'll go back to iPad, and then give me one moment. I'll get it ready. Let's think about this example here. Let's see how much we can do. Okay. Oh, we only got 2 minutes, right? Oh, I didn't realize that. Okay. How about 3 minutes? Okay. Yeah. Now, look at this method. It's going to be relevant. It's completely relevant. This method here, change at, is going to take an input array, some index, some string over here. What it will do is it's going to change at index I in array, and then to some new elements. Okay? I tell you what, how to implement this is trivial. How many lines? Do you need more than one line? A at position I is simply assigned to NS. Done. If you did it correctly. Do you want me to write it down again? You don't. I don't need to write. Okay, yeah. So now, let's do require and ensure. Okay. So now I do need normal pen. How about require? Do we need any precondition for this? Yeah. What's that? Yeah, something like that, right? I'll write it down. Basically, by the way, IFO array start with index 1 by default. Okay. 1 less than or equal to I, and that's conjunction. We'll talk more. Okay. And I less than or equal to ADA count. Not length. There's no length. Okay. Don't write it in the lab test. You get 0. Okay. So now, final 2 minutes. What will be the post condition? First of all, let me save a little bit of time. Usually, you would tell me the first one. You would say, A at position I is now tilde is equal, like an equals method in Java. Okay, I'll explain a little bit more about tilde, but that's how you compare objects. This one is okay. Is that enough, though? Okay, let me just say one more thing. In order to know whether this postcondition is enough, you want to think about, is it possible to have a very evil supplier which is going to mess up the array in such a way that it will not be caught by this postcondition? Is it possible?
You could put indices that, let's say the array is the size of 5.
Yeah.
You say you want to swap index 7.
Yeah, exactly. How about this? Let's say this is an evil supplier. Evil supplier. You simply say A at position I is assigned to NS. That's the correct one. After that, I'm going to say 8 at position I minus 1 is assigned to null. would that pass this check? It would, because as far as this postcondition is concerned, you only worry about this one here. Now, I want you to think about, and then we are done. Basically, for the entire array over here, A, we say that we're going to modify I, position I, to assign it to NS. This postcondition over here only cover over here. What it doesn't cover is the rest of the array. It doesn't really protect it. But now, how do you specify that? Huh? If you try to check if that's equal to array, the whole array is equal. No, the whole array is. Okay, that's good. So you need, okay, one more thing, 30 seconds. I really appreciate your patience. I really appreciate it. One more. Remember this operator? It's going to be your friend in this course. Over this? By the way, this does not write as this, okay? They are not the same. Okay, we'll start from here from Thursday. Okay, think about how you can express this particular constraint using that. Okay, I'll see you then.